Can you see my screen now?
Yeah, we can.
Okay, cool. And your task in this very tutorial was to run the audio transcription task. Usually your interface looks like that. So you have the audio transcription, you have the some input value to type this transcription, and it should work.
Cheese may prevent nightmares.
It is. Okay, and to do so, let me show you how it works. I don't think you need right now to open this Colab because I'm not sure if it supports simultaneous editing, but I will be sharing my screen. So, and you have this project, you have this notation, and you have this overlap of 3, for example. Your overlap or your configuration might be different, but this is the same project you have run in this tutorial. And now we obtain this data. We can download the data from Toloka, and this data will look like that. So you will choose some columns, you will download the results from Toloka. And if you do so, you'll obtain the TSV file that you need to download, not to download, to upload your Colab. And we will use the library called CrowdKit to perform aggregation of this task. But let me look at the data first. Okay, here's the data set. We have input audio, output results, and some other fields. Cheese might prevent nightmares. And you need to process this data because for every task, for every audio you have 3 responses. And you want to get only 1 response, which is the best transcription you can get. And to do so, let me show this trick. We will use the library called CrowdKit. This is the library released by the Toloka team. And this library includes the implementations of all the answer aggregation methods I showed you a few minutes ago. And beyond this, it also includes the methods for textual aggregation. Because in your case, the response is not a label, but a sequence of characters. And in order to aggregate this, you want to apply the specific methods called textual aggregation or sequence aggregation. This time we will use the method called RASA. And this method is a very recent method that uses large language models to select the best transcription among the provided ones. And let me show you how to do this. I believe I can somehow get rid of this block. Okay. I will provide you with the link in the end, but first we need to install pandas and CrowdKit and the dependent libraries like sentence transformers to run these language models. CrowdKit is available on Python package index, and it is installable in a very straightforward way to make this a success. Okay, we have installed everything. Now we want to load these libraries. It takes some time. Okay, so CrowdKit loaded, sentence transformers loaded. Now we want to open the data set we got. I put there the exact file name that we have downloaded. And let me show you what happened here. Okay, this is the very data set I showed you before. Here are the audio files. Here are the results submitted by the crowd performers. Here are other service fields added by Toloka. We don't need them now. And let us select only the audio files and the transcriptions without the golden labels, because we don't want to run this aggregation on the files for which we already know the answers. So let's exclude these rows. Okay, now we got only the objects without the golden transcriptions. And we actually want to obtain the good transcriptions among the submitted ones. Let me transform this data set to the format the CrowdKit library expects. To aggregate something, it requires a task to be defined as the column called task, the output, and the performer. Having this done, you can obtain the data in the format accepted by CrowdKit. And now let's use the paraphrase Distill Roberta model from the Hugging Face repository. It will be used to select the best transcription possible using the HRRasa method. And if you have used the scikit-learn library before, CrowdKit offers a very similar interface to process your crowdsourcing data with CrowdKit. Let's run it. Okay, first it needs to download some data sets, which is the language model, and it takes some time. And indeed, it needs some time to process your data. This is the language model that runs this inference part, and it's not always that fast. And the step has finished in almost 1 minute, including most of the time spent to data downloading. And having this done, we can just run this obtained aggregated data set, data frame, dfeg, to export the final aggregations. Let's look at them. Here are the file names, your audio recordings, and here are the transcriptions. What is the made from? Where is the smallest bone in human body located? A blue whale's heart is more than 5 feet long, and so on. So these are the past responses submitted by the crowd performers to these very recordings. And thanks to CrowdKit, you don't have to write your own language model. You don't have to write the implementation of the corresponding methods. You can just use CrowdKit that is compatible with other kinds of data, and it is not bound to any specific crowdsourcing platform. So regardless of the platform on which you're annotated your data, you can always use CrowdKit to obtain the best results and get the most from your data you annotated on the crowdsourcing platform. And if you have questions right now, I'll be very happy to answer them.
Thank you, Dima. And I think we can sum up.
I have a question in general.
Yeah, please.
Yes. Imagine that you would like to do keyword spotting. And to ask the one that is listen to the file, we would like to say, okay, from this time to this time, this word was pronounced in this sentence. Do you have something like that?
It sounds like a typical classification task. You present the audio file and you ask the performers the simple question: did you hear this or not? And the answer is either yes or no. And based on this, you can build this interface and you can aggregate the results after annotation using, for example, the David-Skin model, which is the method for categorical aggregation. So it's fairly trivially doable.
Right, but I would like that the person not only say that the word is in the sentence, but also where, in which part of the sentence is.
Could you please elaborate on this?
Yes, we want not only to say if the word is inside of the sentence, but also in which part of the sentence is. I mean, suppose that you have a sentence that lasts maybe 2 seconds, and then the one that is listening is say, oh, the word that you want was said after 1 second and 15 second.
Mhm.
Can you do that? Can
Ah.
the Toloka person can do that?
I think yes. It again is up to how you design the task. If you want to ask for the specific place in which one hears the necessary word, you can organize your task as follows. You can show the audio recording element that allows one to play this recording. And then you show additional bar that one needs to move to match the region, the part of the initial audio recording that contains the heard word. And based on this, you can obtain the position of this bar selected by the performer and then process the responses using, for example, the average position to compute the approximate word location.
Oh, okay. Thank you. Thank you very much.
And experiments of my colleagues showed that a simple strategy as average, just compute the average, works really well. Indeed, you can use some weights like performer skills, and indeed you need to set up some training tasks, but generally average is a good thing to try.
Okay, thank you.
Thank you for the question.
I have a question.
Yeah, please.
If we perform these projects but in Spanish, can we change the transformer model that you are using? Or this is like fixed parameter in your model?
Indeed, you not just can, you should change the model. And
Yeah.
as soon as your model can be found for Spanish or other language of your interest, it must be filled in here. So it's just the standard API provided by Hugging Face, which is the super popular repository of models for NLP. And as soon as you have a model for Spanish, sorry, I have never processed Spanish, it must work. But indeed, it's language dependent. There are some multilingual models that can fit your needs, but I believe the language-specific model must be better.
Yes, we have used Spanish models of transformers, but is there a recommendation of which model? Yeah, we are using the multilingual models that you are mentioning, but why are you using here this paraphrase distilled Roberta base, for example? How can we choose the correct model for the specific task?
I believe the best option here is to just run some evaluation on held out dataset, and you'll be fine. But generally, if you can use some paraphrase model or some summarization model, it must work well.
Okay, thank you.
Thank you for the question.